Alia. Hi, Alia.
Hi! I baked these cookies for you guys. I'm so nice.
It looks delicious. Mmm.
I think it's so good, but it's a little bit undercooked.
The cookies is good, but it's a bit tough. I think it's overbaked.
This is good, but I think it's a little bit too chewy for me.
This one is good and almost perfect. So, which temperature should I reject when baking cookies?
I think the one that Ada ate should be rejected.
Yeah, I also agree because it seems so tough when she ate it.
Yeah, I also agree with you.
I see. But, how to confirm the cookies Alia eat should be rejected?
I know how to confirm it. We can use the method that we learned in this chapter. So, what can we learn from this chapter? Let's get into the important learning outcomes. First, in this chapter, we will learn about determining significant figures. It is about the standards for reporting significant figures in measurement and findings. This ensures that our data is accurate and consistent. Next, there are also the different type and cause of error stated in this chapter. These include comprehending determinate systematic and indeterminate random errors. Recognizing these flaws is critical to increasing the accuracy in our experiment. Then, we will learn how to calculate all experimental data with precision and accuracy. This involves computing the mean, median deviation, standard deviation, and relative standard deviation. This calculation helps us better comprehend and analyze our data. Finally, we will discuss how to determine the Q-test and confidence limit. These statistical methods are vital for evaluating our experimental findings and assuring their dependability. In this video, we'll apply this calculation in practical situation. We're going to focus on to find the outlier for the temperature of baking by the calculation of mean, median, standard deviation, RSD percent, and some information about confidence limit. As seen in the clip before, Alia baked some cookies at different temperature. She wants to know which temperature to reject for the best taste. By using the calculation from this chapter, such as finding the mean and median of her result, she can determine the outlier and find the perfect temperature to bake her cookies. For the first step, we need to find the mean for the dataset first. But what is mean? Mean is the average reading of all data or measurements that are obtained from an experiment. It can be calculated by dividing the sum of replicate measurements by the number of measurements in the set. But how do you find mean? You can see the formula that I include in the slide. From this cookies temperature experiment, the dataset is 180, 182, 183, and 200. The calculation will look like this. So, the mean for this dataset is 186.25. Next, we will move on to the definition of median and how to calculate it. I will also show you guys about the calculation of median for this cookie experiment. The definition of median is it is a value that is in the middle result of a set of data. Median of a set of replicate data is the middle result when the data are arranged by increasing in size. Continue back to our calculation. The two middle numbers for this dataset are 182 and 183. To find the median, the sum of these two numbers are divided by 2. So, the median for this dataset is 182.5. Oh my god, I think I don't remember the next step. Lisa, do you know what the next step is?
Yes, I know it, Alia. So, the next step is to find out if there are any outliers. Before we calculate, do you guys know what is an outlier? Outlier is an outlying value that appears to be different from all other data in a set of replicate measurements. It also can be the result of an error. To determine the presence of outlier, we can use the Q-test method. This is the steps in performing the Q-test. The first one is rearrange the dataset in order from the minimum to maximum. The second one is calculate the mean from the data given. Third one is look for the suspected outlier, that is the value which is far from the mean value. The formula for Q-test is gap, which is suspect value minus closest value, divide by range, which is highest value minus lowest value. From the data, we have 180, 182, 183, and 200. Since 200 is very different from the majority of the data, so we suspect it has the potential to be an outlier. So, we calculate it by 200 minus 183 divided by 200 minus 180 equal to 0.85. The calculated Q value is then compared with the value of Q from Q table. If the calculated Q is less than Q table, the data is retained. But if the calculated Q is higher than Q table, the data is rejected and a new mean must be calculated. This is the table of Q values for rejection of result in Q test. From the table, 90% of 4 data is 0.76. The calculated value is now higher than Q from table, which is calculated Q is 0.85 is higher than Q table that is 0.76. So, the data which is 200 is rejected and a new mean is calculated. The new mean is 180 plus 182 plus 183 divided by 3. And the new mean is now 181.667.
Oh, I know what the next step is. The next step is to find the standard deviation from the data set. Division is to know how much each of the measure differs from the mean, while the standard deviation is more significant quantity in that measures the precision or scatter of sample data set. The formula used to find the standard deviation is the standard deviation equal to the square root of 1 over n minus 1 that is multiplied by the sum of the power of 2 data minus mean. The n minus 1 in the formula represents the degree of freedom, which in the calculation of standard deviation, the degree of freedom is reduced by 1. To find the sum of power of 2 data minus mean, we can use table as it is easier and more organized. Since there is a rejection of data, we need to use the new mean that is already calculated by NISA, which is 181.667. So the sum of the power of 2 data minus mean is 4.667. So this is how we calculated the standard deviation, where the n is changed into 3, which is the count of the data. The result based on the formula shows that the standard deviation for the data is 1.528. After we find the standard deviation, we can use this standard deviation to find the percentage of relative standard deviation, or RSD. The formula for RSD is standard deviation over mean multiplied by 100%. Based on the standard deviation and the mean we got, the result for percentage RSD is 0.84%.
Oh, I remember it now. The next step is we need to know the confidence limit and the confidence interval. We can never determine the true value of the mean for a population of data because it requires that infinite number of measurements we make. Limits are set within which experimentally determined mean, which can be found. Confidence limit is a limit of this range is called. Confidence level is numerical magnitude of the confidence limit. Also, the probability of population mean lies within the confidence interval, which are 90%, 95%, and 99%. Moving to confidence interval is range of estimated value of population mean. The formula of confidence interval is true mean value equal to mean plus or minus with statistical factor times with standard deviation divided by square root of number of sample. To know the value of statistical factor from the table, we need to know the degree of freedom and the value of confidence level. To know the value of statistical factor that we take from the table, we need the degree of freedom and the confidence level. To know the degree of freedom, we need to minus 1 from the number of sample. For confidence level, either 90%, 95% or 99% depend on the question. These are the steps. First, we need to calculate the experimental mean. Second, we need to calculate the standard deviation. Third, we need to check the t-factor table for value at 90 or 95 or 99% of confidence level and degree of freedom. Fourth, we use the confidence interval formula to calculate the limit, like I said earlier. Fifth, we need to write a conclusion. For example, the true value lies within from what value to what value. From this formula, we already knew the mean value, the standard deviation value, and the number of sample, but we didn't know the statistical factor value. So, let's take a look at the table. So, this is the values of statistical factor for V degrees of freedom for various confidence level. So, the degrees of freedom is equal to V, equal to number of sample minus 1. So, we have number of sample, so we have 3 number of sample minus with 1 equal to 2. So, if we take 90% of confidence level, the value of statistical factor is equal to 2.920. So, we already have the values that we need. First is mean. Mean is equal to 181.667. Next, statistical factor is equal to 2.920. Next, standard deviation equal to 1.528. And lastly, the number of sample, which is 3. To calculate the true mean value is equal to mean, which is 181.667 plus or minus 2.920 times with standard deviation, which is 1.528, and divided by the number of sample, which is 3. So when the statistical factor times with standard deviation, we get 4.462. From that value is divided by square root of 3. Then we get 2.576. So the confidence limit is the true mean value equal to 181.667 plus or minus with 2.576. To know the confidence interval, the mean, which is 181.667 plus and minus with 2.576. The confidence interval is 179.091 is less than or equal to the true mean value is less than or equal to 184.243. In conclusion, there is 90% of chance that true mean value lies within range 179.091 to 184.243. In a nutshell, we have successfully known how to determine the outlier and calculate the mean, median, Q-test, deviation, standard deviation, confidence limit, and confidence interval. Oh, I found the solution now. Thank you for helping me. Bye.
Bye. Do you think the cookies that Alia make is good?
I really don't think the cookies is good enough.
Yeah,
Me too.
actually it is bland.
That's all from us. Thank you.
Bye.